Hello, hi. So we are now in chapter 5. So it's an electromagnetic induction. So first of all, we're going to look at 5.1, which is about magnetic flux. Okay, so magnetic flux, the symbol will be, this is what we call as phi. So this will be the symbol, it's a Greek symbol, it's a phi. So by definition, basically, magnetic flux is number of magnetic field lines passes through an area. So it's up to the questions whether the area is going to be coil, rectangular coil, a circular coil, a sphere, whatever area they're going to give you in the questions. Okay, for example, in this one here, first part here, we got the X, which is X is magnetic field into the page. So this is a circular coil. So for this surface, for magnetic flux, it's going to count how many magnetic field line that passes through this area. So for example, this is 1, 2, 3, 4, 5, 6. So the magnetic flux will be 6 Weber. Okay, WB, which is SI unit for magnetic flux. Okay, so ataupun for this part here, so we have this side is north, here it will be south. So in what directions is the magnetic field? Okay, so it will be to the right. Okay, so now we have an area here is a rectangular coil. So how many flux there? Berapa? So 1, 2, 3 magnetic flux. Okay, because we have 3 magnetic field lines that passes through the area here. Okay, you gotta remember that basically magnetic field lines is imaginary lines. So normally we know that when you hold a magnet, there is a magnetic field around it, but we can't see it. Okay, so this is basically imaginary line that kita lukis in purpose that you are able to see the presence of magnetic field. Okay, so in other words, there are the names for magnetic field, which is magnetic flux density. Flux density. So sama je lah, there are two names for it. Okay. Okay, so for the equation we have this is for magnetic flux. So it's a phi equal to BA cos B dot A. To get rid of the dot is equal to BA cos theta. So the theta will be the angle between B and A. So A will be perpendicular to the surface. Okay, so there is magnetic flux. The other one is magnetic flux linkage. Okay, ataupun in other words is total magnetic flux. Total magnetic flux lah. Okay, for this linkage or total magnetic flux, kita notekan dia as phi L equal to NBA cos theta. So N is number of turns. Okay, as I said, this is a total magnetic flux. So for example, at the above here, so tadi we only have one turn. Okay, for magnetic flux, the N equals to 1 basically. For one turn only. Okay, so for magnetic flux linkage, basically we have so many turns. Kita nak tahu berapa, dan kita nak total magnetic flux that passes through this total coil. So that's why we got to times by number of turns. So for this kind of question, it's either the question straight away asks you to calculate the magnetic flux linkage or calculate the total magnetic flux magnetic flux of the coil. So kena total tu you kena kali dengan number of turns lah. Okay, so all the information about flux, it is a scalar quantity. What does it mean by? Means that our answer going to have magnitude only. There will be no direction because it's scalar quantity. So the SI unit is Tm squared or Weber. So normally we're going to use Weber lah, because this will be the SI unit for magnetic flux. Okay, so for here I have 3 cases here. Okay, so for the first A here, what is the angle when the plane is perpendicular to B? So here will be my B. For example, if I said my B is to the right, so the lines will be my magnetic field. So this will be my coil. So when the coil is perpendicular, lying perpendicular to the field, the angle will be, so if you look at here, theta will be the angle between B and A. So for this case, your B will be to the right, so this will be, then you punya A akan ke kanan juga. Why is it to the right? Because angle mesti berada 90 degree to the area must be 90 degree to the surface. So this will be your punya area, so this will be your B. So the angle theta here will be 0. Okay, what is the angle if the plane is parallel to B? So parallel to B, so A awak will be down here, for example, or up, above, so this will be your A, so the angle will be 90 degree. So from here you can see it's like, if the angle is over here, okay, so this will be, this is number of fields that are going to pass through an area, but when the coil is parallel to B, there are no lines that are going to pass through your area or your coil, therefore the B flux akan jadi kosong. Kenapa? Cos 90 is equal to 0. Okay, so when your plane is making an angle 30 degree to B, so this is your plane ataupun coil, make it 30 degree to your B, so the angle will be, bukan 30 degree so the angle will be here lah. So because A awak must be perpendicular to your plane, so this is your plane, this is your A must be 90 degree. So the angle theta is the angle between B and A, so theta will be berapa? 90 minus 30, so dapat 60 degree. Okay, you gotta be careful on the theta.